music for a child's heart, body, and mind.
Good morning, Sardonyx. How are you all doing? Welcome to another mathematics class. I want you all to pay attention as we look at a new topic today called binary and decimal. Like I said, it's a new topic, and I want you all to pay attention as I take you through this new topic. Let's go through the topic. Alright, binary and decimal. So I would like to introduce the topic and define each term so we can have a good understanding of what we are talking about. I will start with binary. Now, binaries are numbers in base 2. The word bi always means 2. So numbers in base 2 are called binary. Now, they are formed by any combinations of ones and zeros. They are formed by any combinations of ones and zero. Now let's take a look at what I'm talking about. For example, you are counting numbers 0, 1, 2, 3, 4, 5, and so on and so forth. So we are considering number in base 2. So what used to form numbers in base 2 is any combination of the numbers before that particular 2. And if you look at what we have here, the numbers before 2 are 0 and 1. So any combination of 1 and 0 is used in forming binaries. So a good example of what I'm talking about is something like 1, 0. So because we are talking of binary, which is any combination of 1 and 0, so if I have 1, 0 like this, I can't really call this a binary or a base 2 number. Why? Because the base 2 has not yet been indicated. So how do I make it binary? I will actually put a subscript, a little 2 under here, to make it a binary number. So when you see this now, it is a binary number. Why? Because it's a combination of 1 and 0 and the base 2 is indicated. Mind you, because it's binary, we don't call it 10 base 2. We call it 1, 0 base 2. Another example could be 1 and 1. Like I said, it's any combination of 1s or 0. So when you have 1 and 1 and you have a subscript 2 here, it's also a binary. You call this 1, 1 base 2. You can also have something like 1, 0, 0 and you have a subscript here. So you can call this as well 1, 0, 0 base 2. You can have 1, 1, 1 base 2. This is also binary, and so on and so forth. Don't forget, it's any combination of 1s and 0s, and the subscript, the base 2, must always be indicated to show that the number you're talking about is in base 2. Numbers also exist in other bases, number bases. Of course, I've talked about base 2, that's binary. For example, you can also have something like base 3. Now, when you're talking about base 3, that is ternary, not binary. Now, for base 3, it will be formed by any combination. Since you're talking of base 3, so you will look at the numbers before 3. That is what you use in forming numbers in base 3. So, numbers in base 3 will be any combination of 0, 1s, and 2s. And the subscript will be 3. For example, you may have something like this, 2, 0, 1, subscript 3. You can have something like 1, 1, 2, subscript 3. Now this gives you numbers in base 3. Numbers in base 4 exist as well, base 5, and so on and so forth. But don't forget, our focus in this topic is binary, that's base 2, and decimal, that's base 10. Don't forget, binary base 2 and decimal means numbers in base 10. So I'm trying to explain other bases for you to know that other bases as well exist. Alright, we'll quickly go to the second component of the topic, decimal. Decimals are numbers in base 10. I repeat, decimals are numbers in base 10. And they are formed by any combinations of numbers from 0 to 9. Because we are considering base 10, so we use all the numbers that exist before 10 to form numbers in base 10. And that is from 0 to 9. So, example of numbers in base 10 could be something like 2, 8, 9. If you look at the 3 digits I have here, there are numbers from 0 to 9, which are numbers that exist before the 10 we are talking about. But one unique thing about decimal that you need to know is that in decimal, you do not need to put subscript 10. You just leave it this way. Anyone who sees this can tell that this number is in base 10. But for other bases, you can always indicate the subscript. For base 2, you have subscript 2. For base 3, you have subscript 3. But for 10, you do not really need to put subscript 10. So this number now, we are seeing it without any subscript, means this number is in base 10. Another example could be what? 3, 5, 8. Leaving it without a subscript 10 means it is base 10. Now let's quickly look at something. There is a difference between this and this. Now you see, this is 3-1 subscript 4 and this is also 3-1 without any subscript. Now the difference between these two numbers is that this one is in base 4 because the subscript 4 is here. But this one is in base 10 because there is nothing written here as a subscript. So how do you call this? 3-1 base 4. How do you call this? 31 because it is in base 10. So I need us to note this difference. You can also have something like this. 2-6 base 7, and you can also have something like this, 26. This is in base 7 and this is what? In base 10. So base 10 is so unique that you do not necessarily need to write the subscript 10 there. But for other bases before base 10, the subscript must always be written. So I really want to believe you understand the definition and introduction of each component of this topic. So the next thing we are going to consider now is how to convert numbers from decimal, that is base 10, to binary, that's base 2. I repeat, we are going to look at how to convert numbers from decimal, that's base 10, to binary, base 2. And I want you to pay attention as we take examples. We're taking the next subtopic, which is conversion of decimal to binary. How to convert from base 10 to base 2. Alright, we quickly have an instruction here that will guide us. To convert a decimal, this number in base 10, to binary, divide down the decimal by 2. What do we mean by that statement, divide down? You divide until you get to 1. You're taking it down. So divide down the decimal by 2 and take note of your remainders. Right now, this instruction may not really make sense to you, but by the time we apply it to 1, 2, 3 examples, I want to believe you will understand it. So let's take examples. Instruction will be convert the following decimals to binaries. Okay, number 1. Let's say number 5. Now, me looking at this 5 without any subscript here shows that this 5 is in base 10. I really hope you've not forgotten that. So 5 is in base 10, which is a decimal. Now we have to express this 5 as a binary. Convert 5 to binary. So following that instruction, what you do is you do your line for continuous division. So what you have to convert, you put it here, which is your 5. And the instruction says divide decimal down by 2. So I will start dividing 5 by 2 until I get to 1. And I will take note of my remainders. So I start by dividing with 2. So 2 will go in 5 how many times? Of course, 2 will go in 5 2 times. There is a remainder 1. I'll put it here. I'll keep going until I get to 1 here, like I said. So you keep using your 2 repeatedly. So you use 2 again. How many times will 2 go in 2? 2 will go in 2 once. Any remainder? No, that's remainder 0. So I've gotten to 1. So I will now use it for the last time. Once you get to 1, you now use that 2 for the last time. Okay? 2 will now go in 1. It is not possible because 2 is bigger than 1, right? So when it is impossible, you write 0, which means it can't go. Then remainder the 1 because the 1 is still remaining. It can't go, so it's impossible. Your 1 still remains. So once you get to this impossible remainder 1, you stop. That's the end. So the next thing to do now is to come to your remainder column. You now draw an arrow pointing upwards. What does this arrow indicate? It indicates that you are writing from beneath upwards. So in other words, it means I will write from here, which is what? 1, followed by the next digit 0, and the last one 1. Because I am going to base 2, I will put the subscript 2 here. So therefore 5, which is in base 10, as a binary is equals to what? 1, 0, 1 base 2. So this tells you that this is 5 in base 10 and this is 5 in base 2. Example 2. Let's say, for example, you are to convert number 8 to binary. The 8 is in base 10 because the subscript is not indicated here. Lest I forget, all the examples I'm working here, the questions are in your note. You are meant to copy the solution to the example from the video. Okay, so let's get back to work. Express 8 as a binary. What are you expected to do? You are expected to draw your division line. You want to divide 8 down by what? 2. We are dividing by 2 because we are going to base 2. So what you do is you put your 8 here, then you are dividing by 2. So 2 will go in 8 how many times? That's 4 times. What's your remainder? 0. You need to indicate the remainder. Okay, you keep using 2. Again, 2 will go in 4. That's 2 times. Remainder what? 0. You use another 2 again. 2 will go in 2. How many times? 1. Remainder what? 0. Now you keep using 2 until you are able to get to 0 here. So 2 will go in 1 is impossible, which makes it 0. Remainder the 1 because the 1 has not been divided. So you stop at this point. You draw your arrow upwards, which means you are writing this number what? Upwards. That gives you what? The first one, 1, 0, 0, 0. Now your subscript 2 to tell you that it's now in base 2. So therefore, 8, this is base 10, in the base 2 gives you what? 1, 0, 0, 0, base 2. Okay, that's for that. Okay, example 3. Let's take a bigger number now. For example, let's say 25. This 25 is in base 10 decimal, so we have to express it as a binary. So we draw a line. 25 stays here, we divide by 2 because we are going to base 2. Okay. Now, 2 in 25 is 12 times. In case you can't take it once, you can break it down like 2 in 2 is 1. Remainder 0, right? 2 in 5 is what? 2. There will be a remainder 1. Okay. You divide by 2 again. 2 in 12, that gives you 6. Remainder what? 0. There's no remainder. You use your 2 again. 2 in 6, that's 3. No remainder, that's remainder 0. You use your 2 again. 2 in 3, it will go once. Remainder what? 1. Then you have gotten to 1 and you use for the last time. 2 in 1 is impossible, that's 0. Remainder the 1. So you draw your arrow upwards, and that gives you what? Start from here. 1, 1, 0, 0, 1, base 2. So what do you say? Therefore, 25 base 10 gives you what? 1, 1, 0, 0, 1 in base 2. That's your answer. Number 4. Let's take a bigger number this time around again. Let's say, for example, express 97 base 10 in base 2. So what do? Draw your line. And 7 stays here because you're going to base 2 divided by 2. Okay, so if you can't take the 97 at once, you can break it down like I said earlier. So you try by saying 2 will go in 9. How many times? That's 4 times. Remainder 1. You put the remainder here to make this number become 17. So you now say 2 in 17. That's 8 times. Remainder 1. So you divide by 2 again. You have 48. In case you can't do that once, you can break it down as well. 2 in 4, 2. There is no remainder, so you go to the next one. 2 in 8, 4. So it means 2 in 48 is 24. There is no remainder. That's remainder 0. Okay? You use 2 again. You can't take 24 at once. You can break it down. 2 in 2, 1. There is no remainder. 2 in 4, 2. That means 2 in 24 is 12. There is no remainder. That's remainder 0. So you go on. 2 in 12. That gives you 6. Remainder 0. 2 in 6, 3. Remainder 0. 2 in 3. That's 1. There's a remainder here, which is 1. Then you go to the last one. 3 in 1 is impossible. That's 0. Remainder the 1 because you have not divided it. Draw your arrow pointing upwards. Then you copy out the number from the base. 1, 1, 0, 0, 0, 0, 1, base 2. So what do you say? Therefore, 97 in base 10 gives you what? 1, 1, 0, 0, 0, 0, 1, base 2. Let's take the last example for today's class, number 5. So let's take a big number. Let me say the biggest so far. Express 207 base 10 in base 2. So what do? draw a division line. Your 207 stays here, and because they're going to do 3 divided by 2. So in case you can't take 207 at once, you can break it down the way I've been doing it since. So 2 in 1 is what? 1. Sorry, 2 in 2 is what? 1. Next one is 0. 2 in 0 remains 0. Then 2 in 7 is what? 3, remainder 1. Which means 2 in 207 is 103, remainder 1. So you keep dividing by 2 again. 2 cannot go in 1, so you add the second digit to make it 10. So 2 in 10 is 5. 2 in 3 is 1, remainder 1. Which means 2 in 103 is 51, remainder 1. You keep going with your 2. 2 in 5 is 2. There's remainder 1, so you bring it here to make this 11. So 2 in 11 is what? 5, remainder 1. So you keep going. 2 in 2 is 1. 2 in 5 is what? 2, remainder 1. Now you have 12. 2 in 12 gives you 6, remainder what? 0. 2 in 6 gives you what? 3, remainder 0. You keep drawing. So 2 in 3 gives you what? 1, remainder what? 1. And then finally 2 in 1 gives you what? 0, remainder 1. So you draw a line. You can see it's a long one because it's a very big number. So you write from beneath. That gives you what? 1, 1, 0, 0, 1, 1, 1, 1, base 2. So as you see, therefore, 207, that's in base 10, gives you what? 1, 1, 0, 0, 1, 1, 1, 1, base 2. Alright, Sardonyx, this will be the end of today's class on mathematics. I really hope you understand the topic. Like I always tell you, take your time to copy the notes. In your notes, you'll find the example questions, but the solutions are not there. So you expect to watch the video for explanation and copy the solution to the example from the video. It's a video. If you miss out on any point, you can play it backwards over and over again until you're able to catch up with the point. So I will enjoy you all to copy the note, watch the video for explanation, check your classwork and your homework segment. You'll find your question there. Do them and turn them in as soon as you can. See you some other times. Bye for now.